In this video, we are going to learn about PyBuffer subsystem and how it works to make sure that there is no loss of data being archived on the PyData archive. So what is buffering? Buffering is a mechanism that is configured on the PyInterface node where it stores events locally if necessary and forwards events to one or more PyData archives or what is called as PyCollective. So if PyData archive becomes unavailable, the buffering service temporarily stores the data, and once the connection to the PyData archive is restored, the buffering service will send the data to the PyData archive, making sure that there is no loss of data. So now let's see how it's supposed to work. So let's assume a normally working system where the data comes from the data source via the Py interface, and PyBuffer subsystem performs the compression marking. Data passes through the buffer files into the PyData archive, and the points which are marked for compression are not stored in the PyData archive. Let's assume a situation where the connection to the PyData archive comes down. In such an event, data will be buffered onto buffer files. Then once the connection to the PyData archive is restored, data will start normally flowing through to the PyData archive and will get archived. To summarize PyBuffer subsystem, it basically protects against data loss at PyInterface when the PyData archive is unavailable, allows continuous collection of data during network outages or when PyData archive is down, say for example for maintenance, upgrades, backups, or unexpected failures. And finally, it ensures data integrity, ensuring that all members of the collective receive the same data on the PyData archive collectives by fanning data to all collective members. And this is called n-way buffering. We are going to go through the process of configuring buffering on the interface node using PyBuffer subsystem. First off, we recommend that you use a dedicated service account to run your PyBuffer subsystem, which we have already created within our domain. Then we will set up your PyData archive security to have this buffering service account connect via mapping with only the necessary permissions on the PyData archive. Let's go to the PyData archive and create the so-called PyMapping for our service account that would be utilized by the PyBuffer subsystem in order for it to get access to read and write data to PyPoints. So to do this, let's open up PySystem Management Tools. Open up Security and click on Mappings and Trusts. Then click on the new icon to basically create the PyMapping. Let's browse through the Windows accounts by clicking on this button. We know that we are going to be utilizing the domain service account, which is PySchool is the domain, and I can type PyBuffer, PyBuffer, click check names. It resolves it properly, say OK. And now we need to map it to a PyIdentity. Click on the search for PyIdentity button. Select the PyIdentity that we had created earlier and say OK. And if you recall, we had earlier given access for reading and writing using this PyIdentity to PyPoint database. Now that we have done the necessary preparation for PyBuffer subsystem to connect to the PyData archive to read and write data to PyTags, now we can go ahead and start configuring the PyBuffer subsystem. For that purpose, let's go to our PyInterface node, which is PyInt1. Once we are on PyInt1, let's go to Start, All Programs, PySystem, and open up PyInterface Configuration Utility. Then from the drop-down, select the instance of PyInterface for OPC DA that we had created earlier. Now let's stop this interface service by clicking on this button. Once it has been stopped, let's open up the services panel. Let's go to Start, Administrative Tools, and select Services. highlight one of the Windows service and select P on your keyboard. You would note that there is a Windows service called PyBuffer Subsystem. Highlight it, right click and select Properties and select the Logon tab and select this particular option which says this account. Click on the Browse button. Now we need to search for the domain account. So right now it's pointing to pyint1. So click on Locations and select pyschool.int. Now I can type in PyBuffer and click Check Names. Say OK. You need to type in the password as well, which is student, all lowercase, STUDENT, STUDENT. Say OK. Do not start the Windows service. We can even close it. Now we can go and start configuring the PyBuffer subsystem. Let's go back to our interface configuration utility. Let's go to Tools and select Buffering. It gives you this message box, acknowledge yes, to indicate that we want to configure PyBuffer subsystem 4.3. This will bring up the buffering manager wizard. Click on continue with configuration. We need to select now the PyData archive, which is PySRV1 in our case. Once we have checked it, click next. And here we can browse to the service account, PyBuffer, and check name. And we can type in the password, which is student, all lowercase, STUDENT. Click next. It says it's going to be using the service account and using this Py identity, and the operation is successful as well. If you see a different kind of a screen, you need to make sure that you have chosen the service account, which is this one, and we have selected this Py identity as well. So let's click next. Next again. So everything is good. Now we can exit out of this wizard by clicking on this button. This basically brings up the so-called buffering manager, which gives you the statistics. Now nothing is flowing through the PyBuffer subsystem, indicated by the 0 as the total event sent, since Py interface for OPC-DA is not started yet. So before we start, we just need to add the dependency. The buffering mechanism will not collect data unless otherwise it started before the Py interface. If you are already on the General tab here on the Py interface configuration utility, click on Service, and we just need to acknowledge yes to add this dependency. Once we are done, we can start the Py interface for OPC-DA. So as a best practice, we also need to open up the Py message logs by clicking on this button. Let's expand it so that we can see the logs. And now we can come to the interface configuration utility and start the interface service. So it gives you the right number of tags on the PyData archive defined by the point source, which is OPC, and we have 6 tags. That's good. If you scroll up, it will also indicate that it has connected successfully to the OPC server, which is the data source. And if you still go up, It will also give you the information saying that the API connection was successful to the PyData archive as well. You can also see in the logs that the data is coming from the Py interface for OPC-DA is now being buffered. And we also note that events are currently flowing through the buffering mechanism as well. One other point which I would like to bring to your attention is if we go to the General tab, we find the so-called API hostname. In this case, it's defined by the hostname of the PyData archive, which is PySRV1. Sometimes this can also be represented by the IP address or fully qualified domain name of the PyData archive as well. In such a case, the format needs to match in one file, which is called pyclient.ini. So let's open up Windows Explorer, go to C, Program Files, PyPC, select that folder. Then highlight pyclient.ini file, right click and say edit. In here you will see that the buffered server list has the name of the PyData archive. In our case, it is represented by the hostname. Now let's go to our PyData archive and verify that the data is coming in. Once in the PyData archive, let's open up PySystem Management Tools by going to Start, All Programs, PySystem, and selecting PySystem Management Tools. Let's open up Data and select Current Values. Let's search for tags by clicking on the Tag Search button at the top. Now we can refine the tags that we want to obtain using the point source. We know our point source is OPC. We can search. We have got all the 6 tags. We can click select all and say OK. And I can click the update button, and lo and behold, values are coming to the PyData archive. So as a summary, in this video, we went through the process of configuring buffering on the Py interface node using the PyBuffer subsystem and confirmed that the data is also being received by the PyData archive as well.